the final set of notes is actually 3 different shapes, and so I'm going to break it up into 3 smaller videos so you can watch it as time allows. And we're not actually going to tell you what the shapes are until we've drawn them, at least for the first 2. So all we have to do is make a table of values. And so these shapes, unfortunately, do involve a fair amount of just sheer number crunching. So I've got a table. You notice that all the angles are from 90 to 270, which means that we're starting over here and we're working our way around to here. And you can go for any direction you want to. I could have gone from negative 90 to positive 90. And we'll find out why that is once we've come to our conclusions about the symmetry and other things like that. So when I plug in 90 degrees, of course, I have 3 plus 3 sine of 90 degrees. And of course, sine of 90 is 1. And so I get an answer of 6 at 90 degrees. So 1, 2, 3, 4, 5, 6 units up. Then 3 plus 3 sine 120. And sine of 120 is square root of 3 over 2. And we're going to estimate that it's approximately, it's 0.85, but you could treat it as 0.86 or 0.9 or something like that. So if I treated it like it was a 0.9, so that this part right here was 0.9 times 3, which is 2.7, plus 3, then I get a number that's 5.6. And so it really doesn't matter if you approximated it to be 0.85 or 0.8, because your answers are going to be so close that on a grid this small, you're not going to notice a difference. So 5.7. So right inside that 6th grid line at 120 degrees. 150 is going to work out much better. And what you'll notice on these is that the only angles that are going to work out ugly would be the 120 and the 240, because they're the only ones with ugly sine values. So sine of 150 and sine of 150 is, of course, 1/2. And so that gives us a nice pretty answer, 4.5 at 150. So what I want you guys to do is pause it, and I want you to generate the remaining 4 numbers in the table. Okay, so you should have paused it and finished filling in the table. And before I start plotting the rest of these points, I want to make sure you got them all correct. We were in the middle of calculating this point right here. The only thing that changes on these 3 is that down in quadrant 3, the 210, the 240, and the 270, the sine values have the same magnitude, but now they're all negative. So instead of adding to get bigger numbers, you get smaller numbers. So I'm going to plot those remaining points. We had calculated 4.5 at 150 degrees. So 1, 2, 3, 4.5 will be right about there. And then 3 at 180 degrees would be right about there. 1.5 at 210 degrees would be right about there. 0.3 and 0. Okay. Now what I want you to notice is that we haven't generated an entire shape. What we've done is if I connect these points, we've generated that right there. But look at the trig function that's in the equation. The trig function that's right here in the equation has always generated something special that allowed us to come to conclusions after drawing the whole graph. Well, now we need to draw those conclusions with only having half the graph. If there's sine in the equation, then that means it's going to have y-axis symmetry. And that's why the table of values only went from from 90 around to 270. We could have also, like I said earlier, we could have gone from negative 90 to positive 90, but we need to look at the equation and recognize sine is in the equation, it's going to have y-axis symmetry. I need to generate half the graph. And this type of equation doesn't look like your lines or circles. It doesn't have any fractions, and it's the only one so far that has two separate terms. All of our circles were one term. All of our lines were either one term or fractions. So keep inking those flashcards to identify the different kind of shapes, because you need to know at least that this falls into the category of one of the graphs I'm going to have to generate half of. So now that I know what kind of symmetry it's going to have, because of the sine being in the equation, I can generate the remainder of the graph. So I'm going to take, this point's already on the y-axis, I'm going to take this point and mirror image it over here. I'm going to take this point and I'm going to mirror image it. And the nice thing about mirror imaging is I always just swing around. I just rotate around. Then this one would come around here. This one comes around here. This one comes around here. And so you might want to pause it. I'll give you a second to see how fast you're plotting those mirror image points, and we can talk about what kind of shape this is. Okay, so hopefully you've plotted the rest of your points, and don't make it look like this part right here is coming to a sharp point, because it's not. This is actually just a circle where this end of it has essentially been dimpled in, and that dimple went all the way to the pole, and what it generated is essentially a heart. So remember back when you were a little kid and you were trying to draw hearts and they kind of look like that? That's essentially what we just drew. And so we call it a cardioid because of the fact that it does have the shape of a heart. So that's all there is to cardioids. What you need to learn to do is recognize a couple of things. First of all, the cardioids have very similar equations to the next shape. And so what you need to pay attention to is the fact that in a cardioid, you've got two separate terms, but the numbers in those terms will always be the same. Okay? Disregard the plus or minus, because the plus or minus doesn't mean they're the same or different. You want A and A, and A and A. The plus or minus changes the direction of the dimple and the things like that. So two terms, same number in both terms. Then the next thing that you would then need to recognize is what kind of symmetry it has. This equation has cosine in it, so it's going to be symmetric across the x-axis. So that means you have to generate either the top half or the bottom half. So these angles right here would generate the top half of that shape, unless of course both numbers happen to be negative in the equation, but it'll generate one half or the other, and then you would mirror image across the x-axis to get the rest. I still want you to notice that we are not doing any 45 degrees. Okay, we'll give you the decimal approximation for square root of 3 and square root of 3 over 2, but we're not going to give it to you for the 45s. We don't use 45s. So then the other kind, of course, still same A and A, but this time it's got sine in the equation, which is the example we did, which made it have symmetry across the y-axis. So this right here, our table of values generated the left half of the graph, and then we mirror imaged to generate the other half. Okay, so that's all there is for this recording. You can go ahead and stop, and then we'll do the next shape later.